So we already talked about our comparison test for horizontal asymptotes in a previous video, but we're going to do a couple examples, hopefully to help you get a better understanding of how to find horizontal asymptotes. So given a rational function, and a rational function is a ratio of two polynomials, a numerator and a denominator. So what I have listed here is kind of the format I like to use when I'm talking about it. And so each of these polynomials has a leading term of highest degree in the numerator and the denominator. So the leading term in the numerator is ax to the n, and I use n for the power in the numerator, divided by bx to the d. I use d for the power in the denominator, the highest degree. Okay, so what we're going to do is we are going to compare, we're going to be zoning in on these leading terms in order to determine how or where a horizontal asymptote occurs. So we have three situations that can occur. The first situation we could have would be that n is equal to d. So if we have the same degree in the numerator and in the denominator, then we are going to have a horizontal asymptote that's represented by the ratio of those leading coefficients. So in this case, we would have a over b. Okay, so that would be the line for our horizontal asymptote. So our second situation that could occur would be that n, the degree in the numerator, is less than d, the degree in the denominator. And when that occurs, we are always going to end up with a horizontal asymptote of y equals 0. And the third and final situation that could occur would be that n, the degree in the numerator, is greater than d, the degree in the denominator. And if n is greater than d, there is no horizontal asymptote. It is oblique or slanted, and we find that using long division. Okay, so we're going to look at some horizontal asymptote examples here on the next page. So I've written out here a rational function, f of x equals 3x squared plus 10 divided by 9x cubed plus 4. And so we just want to make sure we're zoning in on the highest power in the numerator and the denominator. In this situation, n equals 2 and d equals 3. So if we were to talk about this, we would say, well, n is less than d. And if n is less than d, then we know our horizontal asymptote is going to be at y equals 0. So let's look at another similar example. So g of x equals 8x squared plus 5x plus 1 over 10 minus x squared plus x cubed. So again, we look at the leading term in the numerator over the leading term in the denominator. So my highest power in the numerator, we end up with n equals 2. Now, the leading term doesn't always appear first. And in this situation, the highest power in the denominator is d. D equals 3. So again, we have a situation where n is less than d. And so because n is less than d, we say that y equals 0 is our horizontal asymptote. Let's consider one more example here. I'm going to write example out. And maybe we'll call this guy h of x. So this is in factored form, h times x squared plus 5 over x squared plus 1, x squared minus 2. Now, looking at this example isn't multiplied all the way out. But what we do know is if I were to start foiling in the numerator and the denominator, I would get x cubed plus some other stuff in the numerator, and it would actually be x cubed plus 5x. And foiling the denominator, I would get x to the 4th minus x squared minus 2. So again, we look at the leading term in the numerator and the leading term in the denominator. In this situation, the degree in the numerator, n, is 3, and the degree in the denominator is 4. And again, we have n is less than d, which lets me know I have a horizontal asymptote at y equals 0. Okay, so we looked at 3 different examples where we got y equals 0. So let's do another one. J of x equals x squared plus 9 over 5x squared plus 2x. So again, we have a rational function. If I look at the degree of my numerator and the degree of my denominator, n is 2 and d is 2. And so what we said in the rules for our comparison test is that if n is equal to d, then we end up with a horizontal asymptote, which is going to be a, the leading coefficient in the numerator. We have a little invisible 1 right there, over the leading coefficient in the denominator, which is 5. So here I would end up with y equals 1 over 5. Let's come up with another one. Q of x equals 8 minus x squared plus 5x cubed over x minus 2x cubed plus 5. So as we mentioned before, things aren't always written in descending order. I could rearrange these and I would have 5x cubed minus x squared plus 8 over negative 2x cubed plus x plus 5. And so what you'll notice here is that the degree in the numerator and the degree in the denominator are the same. N and D both equal 3. N is equal to D, which is equal to that value 3. And if the degree in the numerator is equal to the degree in the denominator, then we set this up. This is going to be y equals the ratio of those leading coefficients. So we'd have y equals 5 over negative 2. And I'll do one more example for us. P of x so P of x equals 2x plus 1 times the quantity x over x squared plus 5x. And so what we want to notice here is that, numerator is not completely multiplied out. If I do that, however, I've got 2x squared plus 1x over x squared plus 5x. Of course, I don't need that leading coefficient 1. So again, you see the degree of the numerator is 2 and the degree of the denominator is 2. So my horizontal asymptote is going to be at 1 equals 2 over 1 because we have a 2 in the numerator and a 1 as my leading coefficient in the denominator. And we could simplify that and just write y equals 2. So we'll do one last example, finding an oblique asymptote. And we might have y equals 10x squared plus 2 over x minus 1. Okay, so notice here, the degree in my numerator, n, is 2, and the degree in my denominator, d, is 1. And if n is greater than d, then we have no horizontal asymptote. What we have is an oblique or slanted asymptote. And in order for us to do this, we need to do either long or synthetic division. I prefer synthetic division, and since my denominator, my divisor, is a linear divisor, I can set this up so that I'm going to plug in x equals 1, and then my coefficients of my dividend, the polynomial in the numerator, I would need 10, use 0 as a placeholder, because there is no linear term, and then 2. So we'll bring down the 10. 10 times 1 is 10. We add, we get 10. 10 times 1 is 10. We add, and our remainder here is 12. So this ends up giving me, for my quotient, 10x plus 10. And I started with x squared, so I knew that this quotient, q of x, was going to be 1 degree less than squared, so that would be linear, or to the first power. And that quotient, q of x, is actually my oblique asymptote. So this would be my solution here. And if you went to your y1 and you went to graph this and you said 10x squared plus 2 divided by x minus 1, you'd have to change the window a little bit. But the graph you'd see would look something like this and have that line with a slope of positive 10 and a y-intercept of 0, 10 bounding up to it. So that's our example of how we find an oblique asymptote, which stems off of not being able to find a horizontal asymptote.